Okay, so I'm sorry, I've been awkward in 2 counts already. I've got to dash off because I'm flying to Melbourne tonight, and I've also used a MacBook, which hopefully is going to work because I couldn't get my slides uploaded, so I'm from the awkward squad. It works, fantastic. Okay, so I've got about 20 minutes or so just to talk a little bit about what we refer to quite often now as a paradigm shift in the way we consider or think about brain health. Where we consider the neurodegenerative diseases are diseases that may have their genesis in early midlife, which present in later life potentially as dementia syndromes. And one of the things I think is important to recognize in this paradigm shift is how we communicate these changes, if you like, to the way we've been thinking about things for so long. And some of you will have been at the workshop, which the EPAD project sponsored or supported yesterday afternoon, where we went into some detail about some of the concepts and the things we're doing within EPAD to achieve that. But today I'd also like to maybe focus a little bit more detail on the actual project itself, because I think we hope it's going to make a major contribution to not only understanding the stages of disease before dementia develops, but also concurrently finding better ways of treating those diseases or preventing them progressing to form the dementia syndrome. And I couldn't agree more with Helen that the voice of the participants in our trials, the patients who ultimately will benefit, is being heard very loudly and clearly within the EPAD project, supported in Work Package 6 under the leadership of Alzheimer Europe. So I don't think I've ever given a talk in the last 3 years when I've not shown this slide. So this is my little Ed memoir, but I think it's a fantastic illustration of the concept that underpins what we're trying to do within EPAD. And that is the hypothesis or the proposal that a lot of the disease processes which ultimately lead to dementia do have their genesis in midlife or even earlier. And what that does is it creates an opportunity, if we were to understand those disease processes, to intervene. And that intervention is what we refer to as secondary prevention. Primary prevention is, if you like, when you have no disease and you have no symptoms, obviously, as a consequence of that. So vaccination is a fantastic example of primary prevention, or wearing a seatbelt is primary prevention. But secondary prevention is where there's early stages of disease. And this is applied very often, for instance, in the field of cancer, where through screening you pick up very early changes which you know, if you were to treat earlier, or able to treat earlier, will have a much more profound effect on the course of disease, hopefully eventually leading to cure. So that's the kind of the paradigm that we're working under within the EPAD project and other similar projects across the world. And what this slide illustrates is the fact that the proposal that there's also a sequence of events, biological changes in amyloid beta, which is one of the core lesions in Alzheimer's disease, which precedes the hyperphosphorylation of tau protein inside the cell, which then precedes the neurodegeneration that we can pick up through MRI scanning, which precedes the cognitive impairment or the memory symptoms, which you will maybe find the tipping point for presentation to your GP or to your specialist. And then ultimately, that impacts on day-to-day functioning. And we box, unfortunately, in some ways, that early stage of disease before dementia develops into 2 groups. One is called preclinical, and we define that by having the evidence of disease but no symptoms. And the second is prodromal, where you have disease, but you also now begin to recognize some symptoms developing. But this curve needs to be filled in, if you like, with real data. And that's what the EPAD, one of the main aims of the EPAD project is, to actually be able to understand how these disease processes interact, how they generate cognitive impairment and other potential symptoms. We need massive projects. These are not answers that can be found by doing a study in 20 or 30 people. And the EPAD project, at its peak, will probably have tens of thousands of people in it, all generating huge amounts of data to be able to do fantastic disease modeling using supercomputers actually based in Belgium to do the analytical work that we need to do. We can't cut any corners. We can't assume we know all the answers already and only look for certain biomarkers or certain disease processes, or only look at measuring cognition or behavior in a certain way. So the patients, the participants who will be participating in the EPAD project will spend anywhere up to 2 days being assessed through brain scanning, cognitive evaluation, filling in questionnaires, etc. In doing that, we may understand much more about the biology of Alzheimer's disease before dementia develops. And then ultimately what we require is a team of some of the best and most qualified statisticians in the planet working on these disease models to make sure the numbers are being crunched appropriately to come out with the right answers. And I'll allude to a little bit about what they do in a moment. But then ultimately, if that all succeeds, it's not just about a paper in the New England Journal of Medicine or Lancet Neurology for the investigators in EPAD. What's absolutely critical is that during this whole process, we communicate what we're doing, we share this information with others, we co-design the project with others, and make sure that when we do come up with some answers, be they in terms of risk status or in terms of interventions, we're able to share that with the community it matters to most. So EPAD includes the preclinical and the prodromal targets, if you like, within its scope of work. As well as looking at just the biology and how the biology in the brain can generate symptoms, in these models we also have to incorporate risk factors. And what this slide reminds me is a couple of really important things. Number one is that risk factors may have a different impact or different potency in terms of risk of developing dementia, depending on what point in the life cycle they take place. So, for instance, and I'm not saying this is definitely the answer, it might be that obesity is more of a risk factor in early midlife than it is in late life, okay? But if we took a one-size-fits-all approach to looking at obesity and risk and didn't incorporate in our models the stage or the age of the person, then we might come up with the wrong conclusion. The other thing about this slide is not every person who, say, got an unhealthy diet will develop dementia, and nor does everybody with a healthy diet not develop dementia. So these risks may be important, but they're probably not very strong risks. So for instance, we look at smoking and lung cancer. The odds ratio is about 20 for a smoker to get lung cancer compared to a non-smoker, whereas most of the risk factors we look at for dementia are around about odds ratios of about 1 or 2. So there's an accumulation of risk factors, all of which play an important part, but probably a small part. And for each individual, we then have to map their risk factors, their biology in their brain, their cognitive symptoms, etc., to then be able to come up with what we call a probability model. And that's kind of the analytical approach that we're taking in EPAD. Okay, so in some ways, the 3 steps, if you like, over the next 5, 10, 15 years or so, that we have to take to prevent dementia are, number one, we have to identify the at-risk person. And as I was just alluding to, there are 4 factors that come into those disease models. Number one is the risk factors, both fixed, for instance, your genetic code, and modifiable, like your lifestyle. So we have to measure those. Secondly, we have to look at the cognitive profile of the patient, not symptoms, because remember, these people do not have symptoms. They've got impairments in cognition, maybe very subtle, and we have to be able to measure those very accurately. The third part in this great collection of data is to actually see as closely as we can what the brain's actually doing. And we do that through neuroimaging, and we also do that through looking at spinal fluid, because the spinal fluid is the best way of looking at proteins that are washing around the brain, which may reflect a disease process inside the nerve cells and around the nerve cells. But critically important in these disease models is actually looking at how all of these parameters change over time. So from year to year, we see whether or not the biomarkers are changing and how that associates with the cognitive profile, etc. If we're able to do that, well, we will be able to do that. What we'll end up with at the end of the day is a probability score that every individual can have, that because of your individual profile, we not only know what your risk of developing a future event may be it dementia or decline in some function, we'll also be able to know for you what's driving that probability. So it doesn't become a one-size-fits-all. It becomes very much a tailored approach to managing treatments. It might be reducing modifiable risk factors. It may, of course, be a bit more, in an optimistic sense, in the 2 sides of the same coin, enhancing resilience. There are things we can do to protect our brains as well as just removing risk factors. But for some, where there's evidence of disease, what we might need to do is intervene with pharmacological interventions, and that's what part of the EPAD project is seeking to achieve. And the third thing, one of the biggest problems we actually have is how do we measure success? Because by definition, if you're at a preclinical stage of illness, what do you do to give you assurance that you've changed something that will then reduce your risk of dementia? Your cognition might improve, your biomarkers might normalize, but we'd have to do a 30 or 40-year study to see whether or not those things actually do correlate, or a term we use are surrogates, for actual reduction of dementia incidence. So we have to take a leap of faith in some ways. It's a little bit like taking a statin for high cholesterol. You lower your cholesterol with a statin, not because having high cholesterol causes you any symptoms, but because you know by doing so you're reducing your risk of a stroke or a heart attack in later life. And this is how I imagine we'll be working in the next 10, 15 years or so in our clinics. And this is where, again, the paradigm shift is really quite important to get our heads around as early as possible. So this was published in a paper in the Journal of Prevention of Alzheimer's Dementia just a couple of weeks ago. And this is a figure which illustrates, if you like, in the dashed line going up from left to right, is what would happen to an individual's function, if you like, on an untreated disease course. But if we're able to intervene with a specific pharmacological intervention or combination of interventions, there might be courses like we do in oncology and other diseases. You may go on a course of a disease-modifying drug, measuring its outcome, measuring its efficacy by a biomarker, and if you see that biomarker normalizing, and at the same time you're managing risk factors, then you might have this course affected to the solid line, where the decline or the disease progression is less. So rather than reaching your 90s with a diagnosis of dementia, you reach your 90s with a diagnosis of very early prodromal dementia, enjoying obviously much better brain health through all those years. So tailoring prevention, again, just to re-emphasize the point, there's 4 considerations. Number 1 is the risk factors, both in the top left panel, the modifiable risk factors, the things we can possibly do now to modify our risk of developing dementia, be it looking at diet, weight, smoking, or alcohol. But unfortunately, we can't choose our parents. So our unmodifiable risk factors are genetics and family history. But we could also, within the study we're doing, look at what is it about those genetics? What do they code? What do they do? What's the biology of people with ApoE4 or other genetic risks that will help us to inform some of those disease processes? And then in this modeling, we've also got to look at the cognition, like I said, and the biomarkers to see how that individual as a risk is actually being constructed and what that risk is. So ultimately, like I say, individualized profile which maps onto individualized or tailored interventions. I think we've lived through an era, or we're living through an era where there seems to be a one-size-fits-all approach to treatment, certainly from a pharmacological perspective. I mean, the clinicians in the audience know we're not very good at selecting people who we've prescribed an episode to. We give it to everybody. And I think that's unfortunate because there are some people we know who'd be very good at responding to, or there could be people who are very good responding to donepezil and others who don't do so well. And if we knew that before we started it, wouldn't that be fantastic? We wouldn't expose people to the risks of the side effects of the medication because the benefits could have been predicted as being low. So I think we have to up our game a little bit and make sure that when we get to the future, we're actually using interventions which are tailored to the individual person. Okay, so that's all really nice in principle, but we have a problem. It's building the evidence base. And I think it's sometimes a little bit unfortunate because I often get asked questions by journalists and what like about what can we do now, and I'm a little bit sort of sheepish in saying anything definitive because I'm a bit of a geek. I want to wait for the data. I want to actually give the answers that are accurate and defensible and credible, rather than just saying, well, if we all stop smoking, it'd be fine. I'd actually like to see the evidence for that, but that'll take time, and that's what the EPAD project is doing. And the other problem, of course, is that we don't have any drugs. In fact, we spent a lot of time and a lot of money. And I was slightly embarrassed when Charles introduced me about how many drug companies I've actually worked with and advised, and I seem to be guilty of a lot of failure because there's been nothing coming to market for the last 15 years. And this is actually a slide that Mia Kivipalto, friend and colleague, pulled together 3 years ago, and we could probably add some more dots into that for drugs that have just not quite made it into the inner circle for actually going into clinical practice. And there's a reason for that. And this is where EPAD and the IMI project as a whole realized that we were pretty rubbish at what we were trying to do. We had very bad methodologies. For any of you who've been involved in drug trials recently, you'll know that for every sort of 10 people who come forward to screen to come into a drug trial, maybe only 1 or 2 will actually make it, which is highly inefficient and very costly and obviously distressing for patients who don't make it into the trial. We've also been targeting the wrong population. In my mind, we've been trying to use disease-modifying drugs when the disease is at a very, very advanced stage in the brain. And also there's multiple disease processes going on by the time someone develops dementia. What we have to do if we're going to be more specific with interventions is go much earlier into these preclinical and prodromal stages. We've also probably had drugs that have been fantastic and worked really well, but we haven't actually set up the experiment to measure the outcome properly. So things were getting better, but we didn't measure it, okay? Which again is desperately unfortunate. So what we've done in EPAD is actually again rebooted the whole system to try and look at how we measure the outcome better in this preclinical period, both from a biological and clinical perspective. And finally, and we've probably taken the wrong analytical approach, the statistics that we've been using to drive these decisions have probably been a little bit old-fashioned, dare I say it. And again, within EPAD, we're looking at much more complex statistical modeling to do, and also what we call Bayesian adaptive trial design, which actually means we make decisions on the trial as we're going through rather than just waiting to the end point. So there's a partnership that forms EPAD, and of course I want to highlight Alzheimer Europe, who are obviously playing a critically important role in the whole project at every element of its design and prosecution. It's huge in terms of its funding. It's currently sitting about 64 million euro, and that's just to do the first part. It doesn't include the actual running of the drug trials. So the project itself will probably, within the next 2 or 3 years, have attracted about €250 million euros of funding. This is a big problem, and it needs a big consortium with big ambition and a lot of funding to secure it. The project started in January 2015, and as was highlighted, it's managed and sponsored, I was going to say here, not in Edinburgh, in the University of Edinburgh. So this was the mission statement for EPAD. It's the European Prevention of Alzheimer's Dementia Project, aims to develop an infrastructure that officially enables the undertaking of what I was referring to before, these adaptive proof of concepts trials for early and accurate decisions on the ongoing development of drug candidates. EPAD won't bring a drug to market. It'll bring a drug to what's called phase 3, but it'll bring that drug to phase 3 with confidence that it's going to be successful because you've learned so much about doses and about the right patient population in that phase 2 testing. What we do is we work very, very closely within EPAD with existing cohorts and registers across Europe. So for instance, in the UK, we work with UK Biobank, we work with Generation Scotland, we work with the Prevent Project to find individuals who we believe to fit a particular risk profile a priori, invite them up, as well as some people who we believe are low risk, because there's no disclosure of risk in EPAD, to bring them up to the trial delivery centres across Europe to ask them to join the EPAD cohort. And it's this EPAD cohort, which I mentioned earlier, is going to have tens of thousands of people in it eventually. And they're followed up every year. And some people from within that cohort will be invited to participate in the clinical trial, which is, of course, the ultimate objective of the EPAD project. Somewhat complicated slide, but it's just simply trying to illustrate from left to right how the patients, or the participants, I should say, flow through the project. So they're in a parent cohort already. Like I say, UK Biobank would be a good example. We look at the database within UK Biobank, and we identify people on certain criteria. Do they have a family history? What's their genetic status? What's their cognitive test scores? And we remotely access this data, and we create a list, if you like, that Biobank then contact those people, and they come forward, hopefully, to join the cohort study. And then ultimately, with a lot of assessments within the cohort study, they may find themselves suitable to enter one of the many clinical trials that we hope to run in the project. The cohort study, as I said, is maintained at 6,000 people, but that means if people come out of the project, they're replaced, and that's why we're going to get up to tens of thousands of people in quite a short period of time. Very detailed assessment of their clinical features, their biomarkers, including neuroimaging. They're seen at baseline and at 6 months, and then annually thereafter. And all that time generating huge amounts of data for our statisticians to work on the disease modeling work, to really inform some of those earlier graphs I showed you about what actually is happening in the preclinical and the prodromal period. We've got 2 or 3 slides to go. This is a trial in a very simplistic way. What we want to do is we want to be able to identify early on that a drug's not working. The worst thing we can do in a drug trial is send a drug trial off and running and wait 5 years and then find out it didn't work. It's much better to start a drug trial running and at certain points in time go, actually, there's no chance of this succeeding. Let's stop the drug, let's take the participants off of that trial, put them into another trial if possible, because otherwise you're just exposing people to risk with no potential benefit. And that's the essence of an adaptive clinical trial. And the way we do that is we look, first of all, is the drug hitting the target? Is the biomarker changing? And if it is, and it's positive, then it goes on to the secondary sort of success criteria, which would be against cognition, because ultimately that's what matters most to people. So that's the clinical trial. And this will last for anywhere between about 2 and 4 years. And if successful, like I say, the drug or the combination of drugs will graduate into a phase 3 trial. So tens of thousands of people to be involved. We're currently sitting at 47. We've started. It's good. We're bang on target for where we actually wanted to be because it's such a complicated system. It took us 2 years to actually develop all the protocols and all the infrastructure. They were actually only started recruiting deliberately very slowly in Edinburgh back in May. And that's Julie Duffus, who some of you may know. She's very happy to share her experience of being involved in the EPAD project. She was the first participant in EPAD, and she was actually on the TV, Scottish television, last week because she came up for her 6-month visit to our centre in Edinburgh, and that's her being interviewed about her experience in the project. There's 4 other centres open currently in Edinburgh, Barcelona, Toulouse and Amsterdam, with Geneva and the Karolinska opening very soon. But by the end of next year, probably about 20 centres across Europe will be open. We're started making our scientific voice heard through some pretty high-profile publications, academic publications. And we hope that by the summer of next year, some of our we're starting to look at the data coming through to actually do some of this disease modelling work. So if I'm back again next year, I might be able to share some of that information with you. But like I say, last but not least on this slide is substantial public engagement, things like this, for instance, and the workshop we ran yesterday. Substantial public engagement efforts in place and accelerating quite substantially now that we're live with the project's recruitment. So final slide, EPAD's huge. The driving force for EPAD there was multiple design problems, scientific problems and delivery problems with the way we were doing Alzheimer's trials in the past, and we needed a reboot. We needed to look at the whole thing with fresh eyes and say, how can we do this better? The third point is that the recruitment methodology is hugely ambitious, it's incredibly costly, and it's incredibly innovative. Almost every element of EPAD has been an innovation. But if successful, it will have a major impact on delivering more therapies more quickly to prevent dementia. So I've got to acknowledge some of the people that work in EPAD. These are the working group leads, work package leads, and also a statement from IMI, which I have to show as well, but the acknowledgement of the support that the European Union has given this project. So thank you very much.
Thank you very much, Craig. Do we have questions? We have time for a couple of questions, maybe. Okay, we have a question here.
Yeah.
Thanks, Craig. I think we know each other.
We do.
You'll be pleased to hear that. I really like your presentation because you didn't make my brain work too hard. I followed it fine. Thank you. I have got, my question is around, your diagram in the early bit with all the lines.
Yes.
And you've got it going from
amyloid to tau to imaging to clinical. Yeah.
Yeah, cognitively normal, I think, was the phrase that was there. And that's a phrase I would like to understand your definition of cognitively normal.
Can I go back a slide? What did I say? Oh, okay. I can give the talk again if you like. It'll get there. I might have to change it. If you picked up something which is inaccurate, then okay. That's not my slide. That's Clifford Jack's slide. Yeah. That's just a cut and paste. Okay, I will, because you're absolutely right. Because I think later on I say cognitive impairment, not symptoms. Because by definition, thank you. I'm going to change that. Because you're absolutely well done. Because you're absolutely right. Because that's wrong. And the whole point of EPAD is to try and work out what the subtle cognitive impairments are, though they're not symptoms. So thank you so much for that pickup. Well done.
Yeah, maybe another question. Do we have another question from the floor?
Or another typo that I've made.
Okay, there's another one. The last one.
Okay, yes.
Thank you for your presentation. This is regarding the Alzheimer's drug development strategy, whatever you have. My question is concerning the amyloid plaques and tau protein and all of these complexities. And billions of neurons with all of these complex neurobiological complexities within, which are affected in this disease. And main important thing is the outcome of the disease, which is on the motivation and emotional part of the brain. That is a 75% of the associated cortex, which is involved, and its connection with the other 25% of the cortex. And what do you think that, is it ever going to be that impact on the current human brain?
Yeah. No, I think that's a really important point. And I think what you've highlighted is the brain is exceptionally complicated. And what the brain does is, of course, not just about generating, biomarkers or neurotransmission, it's about who we are as people. And to capture that in a drug trial is really, really challenging. And there's a lot of work going on within other branches of medicine or other branches of science to try and look at better outcome measures called patient-related outcome measures, to be able to capture the gestalt of what actually the individual feels as a consequence of maybe the disease course being modified. We've got a little bit of work going on in that locally in Edinburgh, not so much through in EPAD. But I think the point is that what we're trying to do with EPAD is say, well, if you actually do affect the A beta or the tau early in the course of the disease, the neurons survive. Okay? Whereas what happens if you try and use these drugs later on, it's actually at a point where the damage to the brain is so substantial, unfortunately, that you're not going to make much of a, dare say, you're not going to make a huge difference to those clinical symptoms. And that's what we're finding when we look at these trials. That's not to say drugs can't be helpful. That's why symptomatic drugs are still being developed. And that's why we need to go early to try and prevent the neurons actually dying in the first instance, be it in the 75% or the 25% you refer to.
Okay, thank you very much.
Thank
We
you.
have to let him go, so
Bye.
another applause.